G'day scientists! Are you looking for an IoT kit for beginners? A cutting edge technology that scientists will love? I review two coding science toys, Kitronic IOT Inventors Kit for the Arduino and Kitronic Discovery Kit Pico, which is a Raspberry Pi device. There are links to check them out on Amazon in the description. As usual, I'm going to be rating them on fun, price and what you learn while you're playing. Then I'll let you know whether I think you should buy them. Right, first up, the Kitronic IoT Inventors Kit for Arduino. It cost me $43.50. Okay, inside this box we've got the book that provides the instructions for the kit and the parts to put together to make the development board. Now, I didn't realise when I bought this that you needed to already have an Arduino Uno. Luckily these are pretty cheap, and if you're prepared to be patient, you can actually pick clones up really cheaply from eBay or AliExpress for as little as $3. This book looks really good. It explains what an Arduino is, how to assemble the board, and also all the experiments too. While I'm putting together this kit, I thought I'd explain a little bit about what IoT is and why it's a great thing for a young scientist to learn. So, IoT stands for Internet of Things. It basically describes objects that have sensors inside them and some basic programming that send data over the internet to a central database. Some examples of items that are IoT are connected appliances in your home, like your TV or fridge, if it connects to the internet. And if you have a wearable activity tracker, that's an IoT device too. Security cameras that detect people and pets, they're IoT devices. What's cool from a young scientist point of view is that it combines together the physical world and the software world. It's a great way to learn about coding while seeing something physical that you've created. Not only is it fun, it's also an in-demand skill. As the world gets more connected to the internet and more devices communicate directly to it, the demand for this skill set will grow and grow. Right, now I've assembled together this development kit, you can see there's the Arduino itself, a fan connected to a motor and a servo, and there's this white block on the end with lots of holes in there that is called a breadboard. Breadboards are great for prototyping and experimenting. They require zero soldering and you basically are joining together connections using these little wires with pins on the end. Okay, let's start connecting things up to the breadboard. The instructions go through step by step, showing you which wires to connect to the Arduino and the numbers of the holes they go into on the breadboard. It's a bit like the painting by numbers of electronics. This experiment we're going to make will detect the amount of electricity being generated by blowing on the fan and show you a corresponding number on the display. While I'm connecting up the wires, I'll explain a little what's going to happen. On the right hand side of the board are the output pins, and these pins are going to send electricity to the display panel. The display panel has 7 segments and each one will be connected to an output pin on the Arduino. This means with software we'll be able to make any pattern we want on the screen by telling the Arduino to power up the corresponding outputs. To prevent the display from being overpowered by the Arduino, we put a few resistors in line. On the left hand side of the Arduino, I'm essentially connecting the motor to the input pins. When I blow on the fan, the motor will generate a current and the input pins on the Arduino will detect a voltage which we will read with software. One of the important things to do when building a breadboard is to double check all of your connections to make sure they're correct. The device is pretty sturdy, but it is possible to break it if you connect it up incorrectly. Here's the completed circuit. Now I'm going to write some code to send to the Arduino so it knows what to do. Okay, setting up the software is easy. Simply search for Arduino and then go to the software section to download the IDE, Integrated Development Environment. Install the software that downloads and launch the Arduino IDE. Make sure your Arduino is connected to your computer via the USB cable, and then in the menu select Tools, Board and pick Arduino Uno. Then Port and the port that shows your Arduino Uno connected. For me, that's COM4. Now I'm going to start writing the software that will control the experiment. The language of Arduino is based on C or C++. It is very straightforward to learn and is used a lot in embedded processing. The template it's loaded up for us has 2 sections, a function called setup, which will run once when the Arduino is powered on, and a second function called loop, which will run over and over again while the Arduino has power. The first thing we're going to write is an array that we will use as a shortcut for lighting up the display to show different numbers. Remember, we can only light up the 7 segments, so we have to write some code that translates the number we want to show to the pattern of segments that needs to be illuminated on the display. We're using an array that will hold the power status of the 7 segments. So in this first example, we are making 0. We are lighting up 6 segments of the 7 segment display. So 6 ones and 1 0. Once completed, we'll be able to pass a number to this array and it will return the 7 ones and zeros, telling us how to light up the display. Next, I'm going to set the 7 pins that control the display to be output pins and set the initial state of the display to be not lit up at all. Now I'm creating a new function that takes the input of a number, fetches the segments that need to be lit up, then cycles through each pin on the Arduino controlling the display and sets it to powered on or off to show the correct number. Lastly, in the looping section, I'm going to read in the power generated from the pin we connected to the motor and then set a value to the display. A little delay on the end stops the screen from being updated like crazy over and over. Then we save the file and send the program to the Arduino over USB. Once the program is loaded onto the Arduino, there's no need to have the computer connected anymore. Okay, let's blow on this fan and see what happens. Yes, there we go. As I blow harder, the number increases on the display. Pretty cool. Great instructions and a nice little kit. It's a shame it doesn't include an Arduino in the kit. I think if you're purchasing this kit as a beginner kit, you're probably not going to have an Arduino lying around your house. What I really like about this kit is the simple way it teaches you quite a complex language like C. It's a really good introduction. I'm going to give Kittronic IOT Inventors kit for the Arduino 3 stars for fun, 2 stars for price, and 3 stars for learning. Buy or bye-bye? It's a buy, a really good way to introduce your young scientists to electronics and coding. Next up, I've got the Kitronic Discovery Kit for Raspberry Pi Pico. It cost me $35.95. It comes in this cute kit and includes the Raspberry Pi Pico itself. All you need to provide is a micro USB cable. Just like the other kit, it has a breadboard and some cables to link together the circuits. The Raspberry Pi Pico is super tiny, almost adorable in its tininess. You can see the USB connection on the bottom there. Then finally in this bag you have LEDs, switches and resistors. The book is great, it takes you through the steps to set the board up and also how to connect the Pi to the board. It simply slots in like this. The experiment I'm going to build will put 2 switches onto the board that are momentary switches. These are switches that only let power through them when they are held down. One switch will control an LED that I'm going to mount onto the board. The other switch will control the LED that is on the Pi itself. You might be thinking, where does the software come into this? Well, we're going to write some code that takes the input from the momentary switches and then toggles the LEDs on and off, essentially using software to change the behavior of the switch. You'll see when it's finished. Assembling this kit is just like the other kit. It tells you which holes to place the wires and components into, just like a paint by number. While I'm assembling this kit together following the instructions very carefully, if you found this video useful, please hit the like button. Want to save money and know which science toys are worth buying? Then please subscribe to my channel and hit the notification bell so you can be notified when I next drop a video. If you do subscribe, pop in a comment below to say I subscribed and I'll say hello. I've gone through and double checked all the wires and they're in the correct places. Now I'm going to attach the Pi to my computer, download the software and start writing the code for this experiment. Just like with the other kits, there's a website to go to download the software. Now the cool thing about the Pi Pico is that you can choose which language you want to develop in, including C, C++, or a language called MicroPython. We're going to pick MicroPython for this experiment. It's what is used throughout this kit. First step is to download the MicroPython file and copy it onto the Pi Pico, which will have appeared as a new USB drive on your computer. Then I'm going to download the recommended development environment called Thonny. Load it and select the Pi Pico we have connected. Let's talk about Python a little. MicroPython is a scaled down version of Python that runs on embedded devices. It's a super hot language to learn right now, not just used in embedded devices, but used by almost every single data scientist worldwide. I can't recommend learning this language enough. In Python, you import libraries first to help you do things inside your program. I'm importing the machine library, which controls devices. First, I'm creating 4 variables, one for each of the LEDs I want to control, one on pin 25, the other on pin 10, and 2 buttons, one on pin 0 and the other on pin 1. Next, I'm creating 2 variables that will hold the state of each LED. We'll use this to remember whether the LED is on or off. To begin with, we're setting them both to false, meaning they are off. The next part is a function for button A. The function will take a pin input. If the button is being pushed, then I'll toggle the LED on or off and update the LED state variable. Then I make another similar function for button B, but using the other button and the other LED. Next, I'm assigning a trigger to both buttons that says when the button is pushed to run this function. Finally, I'm writing a loop that will run infinitely to make sure the LEDs are always showing the correct state. So if the variable LED state 1 changes from false to true, this loop will turn the LED on. That's it. Now we send the code to the Pi Pico, and you can see when I push the buttons, they each turn one of the LEDs on, and then pushing again turns it off. We've changed these switches from being momentary switches by using software. I love this kit. It's simpler and has less parts than the Arduino kit, but it teaches you Python, which is a more modern language and is very popular. The Raspberry Pi range of devices is also newer, and while a little bit more expensive, are very flexible. The experiment book is very clear, and I think you will learn lots from using this kit. I am going to give the Kitronic Discovery Kit for the Raspberry Pi Pico 3 stars for fun, 3 stars for price, and 3 stars for learning. Buy or bye-bye? It's a buy. Amazing kits. Your young scientist is going to love this, and they will really learn skills that are useful and fun. What a great week. Both of these kits are great. If you've got time to stick around, I've got some other kits to share with you. Here's another of my reviews of science toys. If you haven't seen it yet, check it out.